All right, so we're here in our Eisenhower account. I'm going to search for SageMaker. SageMaker can do many things. One of the things that it provides us is Jupyter Notebooks. Jupyter Notebooks is one way to write Python code. It's a very common way within the data science community because it allows the integration of code and commentary. You can also write Python in more traditional integrated development environments like Cloud9 or things like Visual Studio Code, Atom. There are lots of other IDEs that people can use. And there are other ways to use Jupyter Notebooks, such as tools like Anaconda or some of the other cloud providers such as Google Colab or Azure ML notebooks. We're going to use SageMaker notebooks here, notebook instances. I already have this up and running, so I have my choice between Jupyter and Jupyter Lab. Jupyter Lab is a newer version of the Jupyter software, and it provides some additional features. I'm going to use the classic form here. Jupyter is a portmanteau of 3 different languages that people often use in data science, Julia, Python, and R. And that was one of the original reasons to create this notebook environment. There are other notebook styles, like there's one from a company called Mathematica, and there's an open source project from Apache called Zeppelin that also makes notebooks. But by far, Jupyter has become the lead way for writing Python code in the data science community, in part because it's really easy to access and start to work with. So we're good to load up here. And so I have a whole bunch of files you'll see here in my environment, and we're going to open up the one for Python for finance, for economics and finance. One of the great things about using the SageMaker notebooks here is you have these examples. There are so many examples of different applications here. So algorithms, you can use other programming languages like R, the statistical language, and these will all give you an introduction. You can see the part here in gray is all going to be code, and it's that mix between code and commentary that has been really powerful in the spread of Jupyter Notebooks in the data science community. Oh, look, you can even write things in other languages. I didn't know that. All right. So here are my files, and I'm going to open up this Python for economics and finance. There are a number of different modules that we'll go through, and we'll start with just a basic introduction to Jupyter Notebooks. So this is my Jupyter Notebook environment. You can see here that I'm running Python 3. I've got text. This is written in Markdown, and this gray part are cells. These cells that have code also have this in with the bracket. And so when I execute this, it's going to change that to a number. So I'll hold Shift and hit Enter. You can see that it is run. That's my line 1, my in and my out. I use Shift Enter to do that. I could also come up here and hit this button that says Run. And you can see that what this has done is taken this to Python, and Python has given the result back, 13. So that's right, that's Python code right there. But my go-to way for running these cells is holding Shift and then pressing Enter. You can see Shift, Enter. It's the most common way people do it. So what I'd like to show, obviously, simple addition is not the reason people use Python. It's used for lots of different purposes, and this notebook environment can be really great because it gives you the result right back directly underneath the code. So this is a block of code that's going to draw a exponential curve. So y equals x squared. We'll hit Shift and Enter, and you can see it drew right here. I've got a title, and I've got my code here. Y is equal to x asterisk asterisk 2. And that's just saying that's the same as squared. And my color is green. if I decide that I don't like green, I can easily come and change this here to blue, and I'll get the same plot in blue. Or I can change it to red very easily. Could also make this, instead of x squared, it could be x cubed. We can accomplish that for us as well. We'll leave it back at x squared. So each time I executed this cell, it actually was changing this number. We can see that again. So right now we're on 7, I'll run it again, and it's moved up 1 increment to 8. So that is a simple plot using Python in a Jupyter notebook. Very basic. The explanation here has some other information you can use if you want to do like a sine curve. We'll deal with that later. But that's a simple example, and I want to show you a more complicated example. I'm not expecting you to understand what this means right now. We will go through this and talk about why it's designed the way it is. But what we have here is code that's going to create a decline curve that's used in oil and gas. In oil and gas exploration, after you produce oil from the ground, the amount of oil that's left is decreased, right? You've taken it from the ground, you've pulled it out for other purposes. And that follows a mathematical formula. There's a pattern there for how much is left. That decline curve analysis is something that reservoir engineers do as a primary part of their job. So I work in the energy space, and this is an example from my work. So this is using real data from an area in the oil and gas industry called the Bakken in North Dakota. So I'm going to shift enter. And what we have, again, is just a plot directly underneath where you have the blue is the actual production of our oil well over time. So these are the number of days it's been running. And that orange is our predicted decline. So that's following a set formula. Again, not expecting to know you to understand how this works specifically, but the point is that what you're seeing is a very sophisticated mathematical formula that's being rendered here extremely quickly, and I'm getting my results back immediately. We've plotted the oil decline curve, but we can also come up here and I can change from oil to gas, just change that word and run it again, and I get the gas production rate and its curve, slightly different curve. So that is decline curve analysis using Python. So the advantage here is now that I've written this code, that it could be changed out really easily. The input data can be changed, and you can still render these plots. So this is pulling from actual production data from the Bakken, but we could take the same structure and apply it somewhere else. And that flexibility is one of the reasons that this is a much better approach than using something like Excel, where it's difficult to take the formulas that you write in Excel and apply them to new data sets. Here, my data and my code are separate, so I can take any kind of data and put it through my code and get the results out. For this workflow, that posting my result right here, this is really useful for me as a data scientist to get a sense of what's happening with my data. If we wanted to make this more of something for like a dashboard, then instead of having it post the result back here, I could have this connected to a Lambda function, and it could send this plot to a web app that I might be hosting and say Amplify to show the result there. We can build all of that out from a Jupyter notebook. Right? So that's all that a Jupyter notebook is. It is a way for you to write your Python code and to put commentary as to what you're doing, and to see your results interactively, and you can go through it iteratively and change things, as you saw here with the different colors. Okay. All right, so that was our first notebook. Let's move on now to some Python basics. What we'll do in this notebook is go through some of the basic things in computer programming, the basic functions that every computer language can do, such as printing a line out, doing loops, and a couple of other important functions here. So my assumption is that you have no background in any computer programming language. If you do, then you should skip this part, where maybe you just want to see how this compares to an alternative language like Java or C++. So one of the things that's nice about Python is that it's extremely flexible. It's used a lot in the data science community for data science models, but it can also be used to create websites, to scrape data, to run databases, to do any number of things. It's often called the second best language for everything, and it's that flexibility that makes it really popular. It is also slow compared to some of the other languages, in part because it's not compiled before it runs, and it's a higher level language, so it's actually being translated in order to run. The advantage for us is it's really easy to read. All right, so let's go through. So we can have comments here. These triple quotes here are separating out a comment. In Python, the single quote and the double quotes are the same, so I can just as easily change this to double quotes here, and I'll do quotes here because Jupyter's trying to help do some prediction. It gave me the extra ones. Double quotes and single quotes are the same. What you can't do is mix. Have double quotes at the beginning and single quotes at the end will give you an error. So as long as they're consistent, you can use double quotes and single quotes interchangeably. So, simple way to add commentary. Traditionally, when we begin learning a programming language, the first thing you want to do is the hello world function. So for Python, we can take, write print and then brackets, so parentheses here, anything within the quotation marks will get printed out, so hello world. If we wanted to change this to hello AWS, we can hello AWS. So simple way to print things out. In the AWS ecosystem, if you write a function and put it in Lambda, anything that's in the print function will be recorded in the logs. So it's a really good way to comment things so you can go back on the logs and debug if you have something running in production. So I've run this before, and you can see kind of my results here. In order to clean that up, I can just come here to kernel, and I'm just going to clear my outputs, and that way we can go through it together. One of the most important parts about any kind of computer language is being able to use an abstraction. So we use variables as an abstraction, and I'm going to have these variables x and y. I'm going to assign them values, and then I can do things with them. So I've got a variable x, and I'm going to say x takes the value of 2, and y takes the value of 5. Then I can tell Python, take x and add it to y, and that's going to give me the result. And 7. Right. I didn't use the print function here, so I'm just getting this back immediately. If you wanted to do this, so it was recorded like in a log, then you would just add here print and my parentheses, and that is the more formal, probably better way of doing it. So a single equal sign will assign a value. So 2 is being assigned here to x. X is taking the value of 2. If I use this double equals, then I can see, are these two things of equal? Are they the same? So no, x is not equal to y in this case. All right. So that's just checking, it's called truthiness, if these things are the same. With using Excel, you're never asked to really declare data types. So you can just start typing in Excel and it will infer what you're doing. And to some extent, Python will do that too. It will take a list of things that are look like numbers, and it will assume that they are numbers or integers. It will take a list of things that have a decimal point and assume that they're floats. But sometimes we need to be very specific about what type of data we're using, because there are certain functions that you can do with one type of data that you can't with another. So I'm going to take my integers and floats. So I'm going to say I've got a value for integer is equal to 5. A value of float is equal to 5.0. Right? So in human language, we would say these are the same thing, right? 5 is equal to 5. Now I'm going to print out the data type. I didn't declare it here, right? It's going to infer it. So I'm going to say, tell me the data type and the value. Okay. So I'm using these brackets here as placeholders, and then after the quotation marks, I have dot format and my variables. Right here, I'm saying, tell me the type, data type for this variable. So I'll hit Shift Enter, and it's telling me that 5 is type int for integer, and 5.0 is float. Right? Float is just a floating point number with a decimal point. Okay. So in Python, you can have variables that take on numerical values, but they can also take on string values. So that would be any combination of characters. In SQL, you have these different ideas of string or char, and they take on different lengths. In Python, it doesn't work exactly the same way. There's just simply a string. A single character is a string. An entire book that was put together could be a single string. So the length of it doesn't matter. So if I take here, and I've got a variable I'm going to make called A, and I'm going to give it a value of hello world. So I've assigned that. I'm going to add a new cell for us. If you come up here and add the plus button, and I'm just going to shift it right here. If I just say print A, it's going to print the value of A. Great, hello world, we know that's working. Now there are certain methods that I can do to a string that are useful, and these are things that can only be done to strings. So I can't do this for an integer or a float, but if I say take my variable, and then this structure of a dot, and then a command in parentheses is going to apply a function to that data. So I'm going to say apply the upper function to my variable A. And what that has done is taken all of those values. You can see here it was written in this case, and now everything is uppercase. I could also take this to lower, and it makes everything lowercase. And that would be useful for any time you are trying to match things together. Maybe you don't care if someone has spelled their name with a capital letter or a lowercase letter. You just want to see if these strings are the same. You can do that. So what I have done here is not change the value of A. If I come back here and say, tell me A, even though I had done this lower, it has not changed the value of A. It just showed me the lower version of it. If I wanted to reassign it, then I could do A equals A.lower. And so now the value of A has changed, and now it's lower. If I want to find a specific character within my string, I can use this function called find. Since I have changed my value here to all lowercase letters, it will not find a capital W because I changed it. So -1 means it wasn't there. But if I change this here to lowercase w, it's going to tell me 6. So Python, in most computer programming languages, begin an index with 0. And so it's counting H as 0, and then 1, 2, 3, 4, that space is 5, and the letter W is my 6th letter. It's in position 6. And understanding how to index that can be really important if I want to find specific parts of a word, or if you use something like Amazon Comprehend for natural language processing, being able to say that the keywords are a certain number of characters into a sentence is important for being able to do some of that natural language processing. Right, so I've talked about integers and floats, and now we've just introduced strings. Let's talk about the next logical thing here, and that would be a list. A list is any kind of grouping of things, and this can be a grouping of things like integers or dissimilar things. So you can see my list here has a combination of, those are all integers, but this last one here is a string. So I'm going to say everything within these square brackets belongs to my list. And then here I'm printing out the value of my list. Right. Now I want to find the 10th item of my list. Remember, we index at 0, so I would say take my list, and then I'm going to use these square brackets and find the 10th item, which is actually number 9 here, and that will tell me the 10th thing here. So for humans, we would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 99. For Python, it's saying 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 99. So that's a way that I can retrieve a specific thing from my list. So I did that by using the brackets. I can also take a section of my list, so a slice of it, from item 3 up to, but not including, item 8. Okay, so it's up to, not including, item 8. Should be here. I can do a number of other functions here. So I can say, tell me the range of a number. So I'm going to create this. So I want to create a new list that's going to start at 0 and go to 10. I can use other things like sum. It's going to be obviously adding things together, and it will do that for me really easily. So I can use sum to take the things in a list and add them together. So I've got a list up here, and let's try and do that. So I'm going to take sum and add these things together, but it doesn't work. And it doesn't work because it was a mixture of integers and strings, right? So it does not know how to add alpha to this list of numbers. If we remove alpha and we reassign it, so now my list does not include alpha, I can come and do the same thing, and I will get the result. Right? So those are some of the basic syntax and programming building blocks that we'll need, that we'll be using later on. Later on, when we're using more advanced things and for computation, these concepts will be really useful for us to be able to make sure that we're talking about the right data, that we're segmenting it properly and getting what we need. Another data structure in Python is called dictionaries. This is something that's just a key value store. So if you're familiar with JSON or JavaScript object notation, we've got a key, we've got a value. We're going to map those together. So I can create a currency map that has my key is Canada, my value is Canadian dollars, so US dollars, and Great Britain British pounds. So I've got a dictionary here, and then I can use the keys to produce the values. So if I'd like to see what is the value for my dictionary when my key is Canada, it's going to tell me it's Canadian dollars. I can add new things to my dictionary. So I'm going to create China, and I'll add my Chinese currency. So that works. Dictionaries can be a little tough to get started with. They're really useful, and they have a lot of flexibility, especially if you want to be able to iterate through things and produce different values depending on a condition. So what I'd like to do is I've got a bunch of ratings for different types of restaurants. So these are my ratings. For fast food, I give it a rating of 0. Italian is a rating of 3. And Mexican, Tex-Mex, I live in Texas, that's top, that gets a value of 5. So I'm going to make this loop. I'm going to go through and I'm going to print off my values, and I want to see my values according to the category I gave them, right? So I want to see that fast food gets a specific value of 0, not that fast food just gets a random value, like we don't want it to get the value of 5. So this, I didn't run this cell, I forgot to assign it. This is going to take my key, so K for key, and my value, V for value, and print out these statements. I give fast food a value of 0, Mexican food, Italian a value of 5, and Tex-Mex a value of 5. So easy way to be able to have my condition, or to print based on a condition, right? Like I want specifically my connection with, given this key, give me that value. Within SageMaker, we use dictionaries a lot. If you're going to use any of the features that are kind of built in, all of the Amazon SageMaker specific algorithms are all going to be based on these kind of key value dictionaries. All right, so that's one way of thinking about kind of a condition. Here's a more formal way, using if and then statements. Right, so I'm going to have x, I'm going to assign it the value of 12. I'm going to say if x is bigger than 10, right, then do this. If this condition is true, then do this. I don't have to say if this is true. This will only execute if this condition is true. And then if that is not true, else, then do this condition, right? So everything else will fall down here. Let's run this. So 12 is in fact bigger than 10. So we get the word hello. If we reassign x to a value of 10, then is 10 greater than 10? No, that's not true. Right? So this does not execute. Instead, it falls here to else, and we get world. If you want something with more than one condition, you can use what's called elif. So I will do elif x is greater than 5, print x. Right. So x is not bigger than 10, but it is bigger than 5. And so elif said, okay, now I'm just going to print the value of x, and it gave me 10. So rather than going to else, where it would have said world, right? This is you can have as many of these as you want. This is not a using lots of elifs is not a best practice for Python, but it's something you could do. It's just not very encouraged. An important note here is that in Python, the spacing is important. So the reason that we know that this print statement belongs to this conditional statement is because it's indented, right? That's how we know. In something like in JavaScript, you would do this by showing curly brackets. So the curly brackets would indicate this thing is a parent, these things are children. Here we're using spacing to do that. The result is it's much easier to read, but it is less explicit. So the spacing is important. If I drop this to here, it's not going to work, right? Because it needed to be indented. Okay, so the indentations are important. You can use tab. In Jupyter, tab will automatically translate into 4 spaces for you. Okay, so that's a conditional. So if something is true, then do this. If something is, if that other thing is true, then do that. Another thing that we use quite a bit is loops. So do something until some condition is met. So in this case, I'm going to say I have a list. It's the same list we used before. For E, and the E is just a thing. It doesn't. It means item. So for every item in this list, I could change this to item here. So for each item in my list, I want you to print that item. Okay. So it went through and it did that. Right. This is a local variable, so it doesn't really matter. If I change it back, it was E, right, it will give me the same result. So just a local variable here that's basically saying for everything in this list, do this action. Okay. So the loops will allow it to go through and do the same thing. So rather than me having to go and say, print this, print this, print this, do everything until it's not true anymore, until you run to the end of the list. Another way of doing this is to go through. So we talked before about these conditional statements, I can actually put a conditional statement in here in what's called a list comprehension. And this is a much more Pythonic way to do it. So I'm going to have x is equal to 12, put it in brackets because I want it to actually be equal to a list of 12. And then I can run this. And so it's checking to see here, is x bigger than 10? If so, then write the word hello, else write the word world for x in my list of x. This is a list comprehension, right? So this needed to be a list. And then for the second one here, this is accomplishing the same thing as my loop up here was, but it's just written as a list comprehension. So print my item for every item in my list. All right, so list comprehensions, one of my favorite things that we're going to do in Python. Python comes with a lot of pre-made functions, so we use the function before for summation. Take these things and add them together. Super useful. Then there are other times we might want to make our own function, something that we're going to be using over and over again. And that way we don't have to write it out every single time. So we can create a function that says, hey, I'm going to give you these two numbers and I want you to add them together or multiply them or do something with them. It can also be used for taking characters. We use it in Lambda for taking the data, doing something to that data and pushing it out. It's all based on functions. And this is how we declare them. You start with def, so you're going to define your function. Your function has a name, it can be anything. Mine's called firstfunc, and then it has to have these parentheses. That structure is really important. That's what you have to create your function. Everything that belongs to this function has to be indented. Right? So my first function is going to print the word hello, and then it's going to print this is my first function. So I've assigned this now to first function, and it's going to work. Right? That's great. If I need to print those words over and over again, this is an easy way to do it. But this function doesn't take in any data to do something with. Right? So what if I actually want to add some parameters that say, I don't know what I want to say multiply, but I want to have a function that does multiplication. And so what we have here is I'm going to create a new function, I'll call it times, and I want it to take in two values. So within my parentheses, I'm going to declare my parameters. I've got an x and a y. And those can be anything, right? But when you create them, you input a value for x and then a value for y. What it's going to do is then take x, multiply it by y, assign that to the value z, and return me the value of z. Right? These are local variables, so they only live in this function, which means I could have x and y assigned other places, and that doesn't matter. For this function, it's only relative to what we're doing here. Okay, so I've created this new function called times. So if I wanted to assign this to a variable a, right, it's not going to work because it's missing positional arguments. And the positional arguments here are x and y. So, and my first func, because it didn't have any parameters, I didn't need to put anything in the parentheses. But for the multiplication function, I do have parameters and I need to add them. So let's look at it here. I'm going to say my function times is going to take the value 4, so that's my x, and the value 5 for y. Multiply them together, and the return value is going to be stored as c. And now I want to print the value of c. That's 20. Right, so this is really handy if I need to go through and do lots of multiplication, because now I don't have to declare every time this times this. I can just say 33 and that number and get the result. We could add to this even more things where it could automatically print the result for us, or it could take more than 2 arguments. Right now, obviously, you might want to multiply, say, a list of things together, not just 2 numbers. But we'll start here with just a basic function that takes in 2 arguments and multiplies them together. Okay. Now in the notebook that you'll have, there are some things for you to try yourself. I hope that people will go through and actually try these. It's just an easy way to get started with Python and try and learn these different parts. The only way to actually get good at this is to start trying, and it can be a little tricky at first, just like learning any kind of language, like a foreign language. But with practice, you can get better, and you can it starts to make more sense. Just like in a foreign language has grammar, Python has syntax that provides the structure that everything needs to be within. And once you understand that syntax, it's really easy to read Python code and to start to write your own Python code to do the different things that you want to be able to do. Okay, so that was an introduction to Python at a high level. We talked about Jupyter Notebooks and how to use SageMaker for Jupyter Notebooks, and an introduction to Python syntax. In future lessons, we'll talk specifically about doing data analysis using a module called Pandas, and how we can take data from like an Excel spreadsheet and start to do interesting things to it. Thank you, and have a great day.